Welcome to this explainer. Today, we're tackling one of the absolutely crucial transitions in modern software engineering right now. We are talking about moving from those hacky, super exciting AI prototypes over to robust, production-grade, single-agent systems. I mean, we've all seen the dazzling demos, right? But what actually happens when you wire that demo up to your live customer database, your queues, and, well, your real money? The gap between a fun prototype and a safe, deployable system is massive. But don't worry, because today, we are going to bridge it. Okay, let's dive right into this with a number. $1,840. That is the exact amount of cash a family had to pay out of their own pocket for an MRI, all because of a seemingly minor oversight at a fictional contact center outsourcer we'll call NorthLight Member Services. They actually had an AI system running in production for 11 weeks. It was called Triage Assist version 1.5. Well, a member whose prior authorization for an MRI had actually been denied got an automated response from this AI saying, "Good news, your prior authorization request is approved." So the member got the scan, the imaging center collected the cash, and within days, official complaints were opened with the Department of Insurance. Ouch, right? Now, you might immediately be thinking, I know this one. The LLM hallucinated the approval. But actually, scratch that. That is not what happened here at all. The root cause was a totally fragile code failure. The agent correctly retrieved the prior auth record. But a few months prior to this, the underlying database schema had drifted. The field name changed from status denied to decision DNI in all caps. The AI system had been built using a handwritten Python check that was just blindly parsing free text JSON. So when it looked for the specific lowercase word denied in the status field, it silently failed. It returned false, and the agent just blindly proceeded to auto-respond with an approval template. It's wild, but this was entirely a failure of software engineering, not artificial intelligence. To make sure we never make an $1,800 mistake like that, we're treating this as a full postmortem. Here is our agenda. First, we'll look at the contact center AI misfire. Second, the single-agent 5-pillar architecture. Third, bounded loops and structured outputs. Fourth, the vital deferral signal. And finally, field-level evaluation methods. All right, let's kick things off with part 1, the contact center AI misfire. So how exactly do we prevent a shiny demo system from causing actual real-world damage? Well, by replacing hope with rigorous code constraints. That version 1.5 anti-pattern that caused the whole incident, it relied on prompting the model to return free text JSON, it had completely unbounded execution loops, and it used super simple booleans that lacked any real context. Compare that to the best practice, what we'll call MemberTriage Agent version 2. This version uses strictly schema-validated objects, bounded retries to completely prevent infinite loops, and highly typed deferral signals. It's a night and day difference. Moving right along to section 2, the single-agent 5-pillar architecture. This is the ultimate toolkit, guys. This comprehensive framework makes the transition to production actually possible. We call these the 5 pillars of a single-agent architecture. Pillar 1, a typed schema. Pillar 2, a tool loop with bounded retries. Pillar 3, structured output. Pillar 4, a deferral signal. And Pillar 5, an eval harness. And look, this specific single-agent topology isn't just theory. It is literally the industry default architectural recommendation for roughly 80% of production cases in 2026. If you skip even one of these pillars, you are functionally rebuilding that same fragile prototype that failed so spectacularly at NorthLight. Let's zoom in on section 3. Bounded loops and structured outputs. Now, what's really interesting about this is the sheer difference in safety and cost between an unbounded and a bounded system. An unbounded wild true loop is, quite frankly, a financial hazard. Get this. During prototyping at NorthLight, a simple malformed member ID confused the agent and it caused the system to blindly run 47 consecutive tool calls in just 38 seconds. That racked up $4.20 in API charges for one single user message. No way, right? By contrast, bounding the loop enforces a strict maximum, say 5 iterations, limiting the agent to 3 tool calls per session. If it hits that ceiling, it safely fails over. Predictable, bounded execution is the absolute floor for production safety. Okay, so the crucial point here is how we handle the data the agent actually returns to us, which is exactly where structured outputs come in. You can use Anthropic's strict tool_use, OpenAI's strict JSON schema, or a great library like Instructor. What these do is force the large language model to return data that perfectly matches a strict blueprint that you define in your code. No more parsing messy free text JSON. If NorthLight had just utilized structured outputs, their code would have rejected the output the very second that database schema drifted. It would have entirely prevented that $1,800 misfire from ever reaching the patient. Which brings us to Section 4, the vital deferral signal. Autonomy is great, but a truly robust agent must know not just how to act, but exactly when it must stop and hand the task over to a human. An agent needs a clearly defined surface to basically say, hey, I should hand this back. We call these deferral conditions. The 5 canonical conditions are low confidence, out-of-domain inputs, sensitive topics, regulated actions, and multi-topic inputs that just confuse the routing. Think back to our anchor story for a second. A prior authorization denial is a highly regulated action that touches State Department of Insurance rules. Under no circumstances should an agent ever auto-respond to a denial. It absolutely requires explicit human review. And this brilliantly illustrates how we take a fuzzy business rule and turn it into an unbreakable law of physics in our code. Using a validation framework like Pydantic, we write a model validator. If the agent's confidence drops below 85%, or if the topic is an appeal, or if the action is to route to a human queue, the system demands that a deferral signal be explicitly fired. If the model tries to return an object that violates this logic, the code literally throws an error and rejects it on the spot. This completely avoids what we call the silent confidence trap, where an agent disconfidently guesses its way into a total disaster. Finally, let's wrap up with Section 5, field-level evaluation methods. So, how do we actually prove this whole setup is safe to ship before it ever touches a real customer? The vital concept to grasp here is whole record accuracy versus field-level accuracy. You see, the NorthLight version 1.5 system looked perfectly fine on paper. It boasted an 83% whole record accuracy rate. But here's the secret. Whole record accuracy hides fatal flaws. If a record has 4 fields and the agent gets 3 low-stakes fields right, but completely fails on the critical deferral signal, a whole record test might just give it a passing grade. When they later ran a field-level evaluation specifically on that crucial deferral signal field, it scored a dismal 31%. To fix this, you create a golden data set. Honestly, even just 10 highly representative rows is a great start. We don't just ask, hey, did the agent get it generally right? We compare every single typed field against the ground truth. So, when the input is a prior-auth deny, the expected category is a regulated action, and the expected deferral absolutely must be to route to a queue. If the predicted deferral comes back as none, the eval fails exactly on that specific field. You simply cannot evaluate what you cannot compare, and you definitely cannot compare free text. Structured outputs are what enable this precise field-by-field scoring. So, I'll leave you with this question to think about for your own projects. Is your single agent system running on strict, verifiable code, or is it running on hope? Hope that the model won't hallucinate, hope that the schema won't drift, hope that the loops won't run infinitely and rack up a massive bill? By actually implementing the 5-pillar architecture, typed schemas, bounded retries, structured outputs, deferral signals, and field-level evaluations, you literally eliminate hope from the equation. Apply these principles before your next deployment, and you'll build systems that actually survive the real world. Thanks so much for joining me on this explainer, and happy building.